This lecture is going to be starting with our second market structure, monopolies. So monopolies, you'll recall, is when you have one producer in the entire market. So that's it. You don't have to worry about product differentiation or the long run because there is no change for this market. Either the firm is in it or it's out of it. So the graph is going to look a little bit different, but there are some similarities that we'll talk through as we go through. So when we're discussing the monopoly, it's important to remember that the demand for the monopolist is the demand for the market. And once again, this makes sense. They're the only producer. And price is set by the demand curve, as it always is. Price is always set by the demand curve. For perfect competition, it just so happened that the demand curve and the marginal revenue curve were the same curve. In monopolies, the demand curve is separated out from the demand curve. Marginal revenue curve is below it. And that's because as the monopolist wants to sell more of the product, it has to lower its price. Therefore, the marginal revenue, as it increases the quantity sold, lowers your marginal revenue. The price falls. So your marginal revenue is going to start at the same place as your demand curve and separate out, as you see on here. So we no longer have a Mr. Darp curve. We do have a DARP curve, if you will. That's the demand curve. So if we think this is our demand curve, that still equals our AR, and that still equals our price. But this curve is now our MR curve. And our MR can go negative, and that should be bringing back ideas of elasticity. Remember, when your marginal revenue is negative, that is the change up of your elasticity on your demand curve. So if you want to take the MR curve where it crosses the x-axis and draw up to the demand curve, we can now clearly see the difference between elastic and inelastic portions of the demand curve. In this upper left-hand portion, that's the elastic portion, because as they lower the price, the total revenue will still increase because your marginal revenue is positive. This portion, where your marginal revenue is negative, that's the inelastic portion, because as you lower the price more, your total revenue will fall because your marginal revenue is now negative. And right where it crosses the x-axis, right there at the quantity of 5, that's unit elastic, because that's when the change in price yielded no change to the total revenue. Now, when you're profit maximizing in a monopoly, you profit maximize the exact same way you did before. Your quantity is still where MC equals MR, and your price is still set by the demand curve. However, once again, the demand curve is now separated out from your MR, so it looks a little different. So if we look at this graph, we see MC is the red curve here, swooshing as always. Our MR is this slightly lighter blue curve here. Where they meet gives you your quantity. That quantity at your demand curve is your price. So the price that's set by the monopolist is on the demand curve at the profit maximizing quantity. Now, this is what's called price searching behavior. In other words, the monopolist can actually change its price and not end up at a loss. So they can increase their price if they want to, say here, they could do that. But they wouldn't want to, because that's not where they'd find the maximum profit. They could lower the price to, let's say, here. But they wouldn't do that because that doesn't maximize their profit. They will go here. So sometimes you'll see people talk about monopolists, they could just set any price they want. That's not true. They can set prices that are higher than the perfectly competitive outcome. They will have higher prices, but they will not just set any price they want. They are still constrained. They will still just profit maximize. They're not just going to increase the price because they can. Now, a lot of that does have to do with elasticity. The more inelastic the demand curve, the higher price that they can actually sell it for. So you do have to consider those things when discussing monopoly price searching behavior. Now, what does this look like when you have profits and losses? It's the same analysis as we did with perfect competition. If your ATC is below your price at the profit maximizing quantity, then you have a profit. So that's on the left-hand side. You see your MC equals MR. I know the MC isn't swooshed here, but this is the best graphic I could find. So just imagine, swooshing MC as opposed to a straight line. If you have MC equals MR, that gets you your quantity. That quantity at the demand curve gets you your price. Your ATC at that quantity is less than your price, therefore you have a profit. If you want to draw the profit box, take that quantity at the demand curve down to the ATC over to the y-axis, and the price, the box that forms, is the profit box. It can once again tell you the profit per unit if you do the price minus the ATC, because that's average revenue minus average price. Or if you want the total profit, you just do the area of the profit box, or the average profit per unit, or average profit or profit per unit multiplied by the quantity sold. Same exact idea for loss, but the ATC is above the price. So your quantity is still set by MC equals MR, so this is the intersection. Take that down, that gets you your quantity. Take it up to the demand curve, that gets you your price. The ATC at this price, at this quantity, is above your price, therefore you're incurring a loss because your average revenue set by the demand curve is less than your average total cost set by the ATC. In order to find per unit, you would do cost minus average total cost minus average revenue, and to find the total loss, you do per unit multiplied by the quantity, or the average of the loss box, or area of the loss box, I should say. Now, can a monopolist shut down? The answer is absolutely. And it's once again found out the exact same way. It's about the placement of your AVC. So if your AVC is above your price, then you shut down. If it's below your price, you continue to produce, even if you're incurring losses. If your ATC is above your price and your AVC is below your price, you continue to produce in order to minimize losses. And it's for the exact same reasons. If your price is above your average variable costs, then you are able to pay off all of your variable costs and some of your fixed costs, even if you're incurring losses. If your average variable cost is greater than your average revenue, well, now you can no longer pay off your variable costs. And if you don't shut down, you're paying off, you will be losing some of your variable costs and your fixed cost. So it's better to shut down in the short run, because that means you'll only have to pay for your fixed costs. A popular question on the AP test is comparing monopoly versus perfect competition. Basically, what are the differences aside from the obvious of what you can see? Well, monopolies create inefficiency. They are a type of market failure. If you're wondering, well, didn't you say if there was inefficiency, there would be deadweight loss? The answer is yes. And you can still see that deadweight loss. I told you before when we were doing taxes that deadweight loss is always formed by the quantity, the supply curve, and the demand curve. Well, you recall that supply is, to a degree, your marginal cost curve. So if we consider the marginal cost curve the supply curve, right here, the demand curve, still the demand curve, and the quantity right there. And there is our triangle of deadweight loss, which lets you know a few more things. It lets you know that there is a perfectly competitive outcome that you can find, because the perfectly competitive outcome will be where supply meets demand, where supply equals the price, where MC equals price, and that is right here. So if you're trying to figure out what would be most socially beneficial, that would be the level of output at that intersection. We'll go over this a little bit more later. But that would be what you're looking for if you're looking for socially optimal. As I said before, you don't have a Mr. DARP anymore. You just have DARP. So D equals AR equals P. Your MR frequently will be depicted as going negative because a lot of times you'll get questions about elasticity along this demand curve. Your DARP curve is obviously not perfectly elastic, and your price is greater than your marginal cost. Price being greater than your marginal cost is another way of saying that there is deadweight loss, because if your price was equal to your marginal cost, that implies that you're at your socially optimal level. This is sort of the setup for the classic monopolist graph. It's making a profit. You have a downward sloping demand, separated out MR curve. Make sure you don't draw them parallel. Make sure you draw them diverging. And ATC intersecting MC at MC's lowest point. If you wanted to draw in an ABC, you could. It would just be located below the ATC, still U-shaped, still intersecting MC at its lowest point. But usually ABC isn't really cared about so much unless you're talking about the shutdown point. Now, if we're thinking about welfare effects and what happens to the consumer surplus versus producer surplus in firms, as you're looking at it, is really the profit. That's the producer surplus, profit. So when we discuss all this stuff, when we say profit maximizing, it's really producer surplus maximizing. Now, the perfectly competitive outcome gives you a greater consumer surplus. So if you think about it, now this red line is representing the price at which MC equals ATC, not saying that there's a perfectly elastic marginal cost curve. It's just representing that as a horizontal line to, imagine a line being drawn across where MC equals ATC. So just for ease sake, think of that being your MC curve going through. So if that's the case, then you would have deadweight loss. Well, that doesn't really make sense on the one on the right. So ignore the one on the right for now. But if you notice, the perfectly competitive outcome on the monopoly is going to have no deadweight loss, whereas the the monopolist outcome will have deadweight loss. That means that a lot of that's coming out of the consumer surplus and making way for profit instead. And this really exists because you have your price being greater than your marginal cost. Now, how do you prevent monopoly power? We always hear the idea that monopolies are bad. So how do we prevent it? First of all, why do we want to prevent it? Well, inefficiency is bad because it causes a higher price and a lower output than when you're being allocatively efficient. You recall, allocatively efficient is the perfectly competitive outcome. It is where your marginal cost equals your price. So where your MC meets your demand curve, or where supply meets demand. So that's something that is a characteristic of a monopoly. It charges a higher price and has a lower output than a perfectly competitive outcome. So frequently you'll have antitrust laws used to prevent monopolization in markets. You also have natural monopolies. Now, natural monopolies are kind of necessary. These are created by massive economies of scale. Such high barriers to entry that it's difficult to actually have any sort of competition. So it's much more efficient to allow the natural monopoly to exist, or to help set it up even. But you do want some regulation to prevent abuse of the pricing power and decrease some of that deadweight loss. So how do you deal with a natural monopoly? Well, you can have public ownership. So think the post office would be a good example of this. So the good here is that the government can purchase and operate the firm, and they're not trying to maximize profit. So they can try to minimize the price as much as possible. If your government can even operate where price equals MC without losing money, well, then there wouldn't even be deadweight loss. And that's awesome. You think about, if you really think about what is going on when you mail a letter, you can mail a letter across the country. Somebody will take a physical piece of paper from you, take it all the way across the country for less than $1. It would be difficult to find an individual willing to do that, or even a business willing to do that. So they're able to keep the post office at absurdly low prices, really. And granted, it's not the best run. There are plenty of issues, and that's where the bad comes in. It's bureaucracy and politics usually have trouble keeping costs low, and this has been a major issue with the post office. Adding to the idea that they are piled on with laws and regulations because they're publicly owned that increase costs like crazy. So when people say the post office is mismanaged and that's why it's losing money, that's only really part of the reason. The other part is Congress pushed a lot of that onto the post office for political reasons in many cases. The other way to deal with a natural monopoly, and this is what shows up much more often on the AP test, is regulating it in terms of price. So this is an important graph for you to make sure you understand. So let's take a look at this. Now, first of all, let's imagine that this MC curve continues up in its swoosh-like motion like normal, and the ATC continues up in its U-shaped motion. Sometimes that confuses people. So this is our monopoly, and we are trying to regulate it. We have to think of a few outcomes. First of all, you have your monopoly price, the one where it's set if it's left to its own devices. And that's your MC equals MR outcome. So MC is this orange line, MR is the gray line, where they intersect to get you your quantity. That quantity at the demand curve gets you your price. That's the unregulated outcome. It's earning a profit there because the price is above its ATC. The fair return price, sometimes referred to as the break-even price, that would be where it is making a normal profit. So that's where price equals ATC. So if we look at price being set by the demand curve, where ATC intersects right there gets you your fair return price. The quantity, of course, is just the same quantity there. So QF and PF here. That is somewhat ideal because it does lower the price, increases the output, reduces deadweight loss. However, you still have some deadweight loss. So there is an issue there. Now, if that's acceptable, that's great. If that's unacceptable for society, well, then you have to try out the next one. And the next one is the socially optimal price. And that's where your marginal cost equals your demand curve, as I'd said before. So where MC meets demand, that is your price, that is your quantity. This is the perfectly competitive outcome, the socially optimal outcome. This is the way that you eliminate deadweight loss. Now, the problem is, in a lot of cases, as is shown here, your socially optimal price would force this monopoly into a loss. So if they have a loss, well, they're not going to stay open. So you can't necessarily do this unless you subsidize them. A subsidy is a payment to a firm to do something. So if they pay the firm to produce at this level, then they can lower the costs associated with it until they're able to either earn a profit or a normal profit. So that's an important distinction there, and that frequently shows up in the AP test as well. That in many cases, to regulate to the socially optimal price is going to require a subsidy paid to the firm. That's all you have to know about monopoly graphing and regulating. There is one more part of monopolies that you have to know, and that has to do with price discrimination, and that'll be covered in the next lecture.